Hello genius minds, this is Newton Backyard. So welcome to my another video. So according to our series, in this video we are talking about laws of conservation of momentum. I mean law of conservation of momentum. So it means that total momentum before a collision is equal to total momentum after a collision. I mean, for example, there are two cars. If one car has greater velocity than other car, and they both have mass, obviously, and the car with the higher velocity is behind the car with with comparatively lesser velocity, then the higher velocity will, after some time, will just get crashed into the car with lower velocity, and that's what the total momentum of that scenario means. Before the collision is equal to the total momentum after the scenario. It means that the momentum of both the cars may change before and after the collision, but the total amount of momentum will remain the same. So we have to prove that why total momentum before collision is equal to total momentum after collision. So let's start. We have to prove that, okay, let's just write the heading that law of conservation of momentum. That's a very serious topic because we learn it in the 11th and 12th as well, and that is quite complicated there. So you have to prove, and that's a big proof. You can, in the exam perspective, it is about 5 marks of derivation. Okay, proof that total momentum before collision, I mean before crash, is equal to total momentum after collision. Okay, so here we need I think two things, and that first thing is that the momentum, the total momentum of the car 1, okay, car 1 or the body 1 with mass m 1, and the other second thing is that the total momentum of the second body with velocity, with some velocity and mass m2. So let's write down that thing. So for the illustration we have to draw some diagram. The first column will be before collision, and before collision then we have to write during collision, during collision, and after that we will write after collision. Okay, so after that we will make some column 1 2. Okay, so we have here an object m1 with some initial velocity u1. We are depicting an object with m1 with initial velocity u1, and we will name that object a. Suppose you can name it as b, your choice. Okay, it depends on your choice, but for the best illustration I am taking it as a. And another object with m mass m2 and initial velocity u2, and the object's body is b. During collision means when they two crash, because the initial velocity of m1 is greater than m2, initial velocity of m2, hence they will collide after some time. It means that m1 touches m2, here a b, okay, their name, a touches b after some time, and then again m1 will have some final velocity v1, it's a, and m2 will have some final velocity v2 as b. Okay, so here we have three scenarios: one that before collision, that during collision when they are touching each other, and the last one is the after collision, means after the scenario. Means here we have got the initial velocity, then we have got the final velocity. So let's write down that let two bodies, so we have to just look into this, what we are looking into this, we write it in the paper to prove. Okay, bodies, okay, bodies A and B having masses m1 and m2 moving with initial velocities, we are talking about both of the velocities u1 and u2. As you can see, m1 have initial velocity u1 and m2 have initial velocity u2 respectively. Okay, means this one is for this one and this one is for this one, that's respectively, you can say, in a straight line, because as we are reading motion in a straight line in class 9, linear motion in 1D, one dimensional line with uniform speeds, means the both are of uniform speeds, but the speed of A is greater than the speed of B, otherwise they will never collide in the future time. Okay, that's some relativity. Uniform speeds. Okay, so here we got the first part, and from this, so the total momentum before collision, we are right. So the total momentum before collision, okay, let's off that, fit in the camera. So total, first we have to find the momentum of the object A. So body A has momentum m1 multiplied by u1. Okay, formula momentum is mass of the body multiplied by velocity of that body. So here we write m1 multiplied by u1 plus total momentum. It means we have to also find the momentum of object B or body B, and that's m2 multiplied by u2. Okay, so I found the total momentum of two bodies before collision. Now we have to find after collision scenario. Let's write, let body A moves faster than body B. As I said, that if body A is moving faster than body B, then in the future time it is possible that body A will somewhat crash into or collide into body B. So moves faster than body B. Okay, my voice. U1 is greater than U2. Okay, so after some time t, I am talking about some time. Time is very important. Some time t, they collide. As I said, they collide together with each other. Okay, with each other. That's actually the correct way to write that two bodies got straight into each other, collide with each other. Okay, now we have to write and move at different speeds of v1 and v2 respectively. Okay, so what happened here, that after the collision their velocities changes. Okay, and the change of velocity is non-uniformly, they change their velocity non-uniformly. You can say they are non-uniformly accelerated bodies, and that's why their velocity changes non-uniformly, because in a collision that's a very little chance that they uniformly accelerate. Okay, so we have to write here that, so the total momentum after collision, and this is the complete, you can say complete proof of this thing. that total momentum before collision is total momentum after collision. So here the momentum of body A, okay, the momentum of body is equal to m1 multiplied by v1. So we will write m1 multiplied by v1 plus, here we got m2 multiplied by v2 is the momentum of body B after the collision. So you got m2 v2. Okay, we will simplify it as m1 v1 plus, sorry, m2 v2. I read it incorrectly. M2 v2 plus m1 v1. Okay, I just get a little bit wrong. M1 v1 plus m2 v2. Okay, so we got here m2 v2 plus m1 v1 plus m2 v2, and that's the total momentum after the collision. You can write m1 v1. Okay, that's a small mistake, negligible mistake you can say. Okay, so after that we have to write something, and that's on the during collision process. The during collision Newton's third law of motion is acting, and you have to write there so that we can prove that total momentum before collision is equal to total momentum after collision. So let's write that. During collision, okay, during the collision scenario, you can say during collision the body A exerts some force F1. Okay, so here we have to take the force exerted by body as F1, because we are also writing the force exerted by body B as F2, because according to Newton's third law every action has a opposite and equal reaction, and that's why if body A exerts some force on body B, then body B in return will also exert some force on body A. So you have to write that, okay, on body B the amount of force exerted by body A on B is equal to the mass of body B multiplied with its acceleration. So we are writing that the force exerted by body A on body B is equal to the mass of the body B multiplied by acceleration produced in it. Okay, so here we will write F1 is equal to body B is taken a mass m2 multiplied by its acceleration is equal to m2. We can write acceleration as b minus u by t. Here we are writing v2 minus u2 by t, because we are talking about the velocities of body B. So here we got u2 and here we got v2. So acceleration is equal to final velocity minus initial velocity v2 minus u2 by t. Okay, and you will got equation I. So taking the next paper, this paper is over. Okay, so we'll continue with it, that in that time the body also exerts the same amount of force, and we're talking about which body? We're talking about body B on which the force is acting. Force, and this force is known as F2, as I said earlier, on the body A. The amount of force exerted by body B on body A, i.e., you can say i.e., F2 means force 2 is equal to mass of A multiplied with its acceleration. Mass, okay, let me focus. Okay, that's fine. Mass of A multiplied with its acceleration, which is F2 is equal to m1, that is mass of body A multiplied with its acceleration, is equal to m1 is equal to b1 minus u1 by t, and that will got equation double I. So if we look into the previous paper, we will know that body A has respectively velocities v1 and u1. So to find its acceleration, you have to do v1 minus u1 by time, and that's rate of change in velocity. So according to Newton's third law is involved in this. So one of the famous students says that using the laws of motion, you can complete half of the physics in your life if you want to become a physicist. F1 is equal to negative F2. Why we are taking negative F2? Because if you're trying to find a force, then according to Newton's third law of motion, action is opposite direction in reaction, or reaction is in the opposite direction of action, and that's why we are taking it as negative, because direction is negative. So we can write that here F1. Okay, so if you look into this, so F1 is equal to m2 whole into b2 minus u2 by t. You can write here there that m2 whole into v2 minus u2 by t, u2 by t is equal to negative, that's a negative sign, m1, and that's already in bracket, b1 minus u1 whole into by t. Okay, so implies here t cancel out, m2 v2 minus m2 u2, m2 is multiplied by both of the velocities, is equal to minus m1 v1 plus m1 u1. So why minus multiplied by minus, negative multiplied by negative converted into positive? Okay, that's simple mathematics. Implies m1 v1 plus m2 v2, we are just changing the side, you can say m1 u1 plus m2 u2. Okay, we got it that again if we get the implies m1 u1 plus m2 u2. Okay, we're just putting this here and this here, LHS to RHS, RHS to LHS is equal to m1 v1 plus m2 v2, and that we have to prove the total momentum before collision is equal to total momentum after collision, and we have proved that. So thus we proved that total momentum before collision is equal to total momentum after collision. Okay, so I think we have come to the end of this video. In the next video, I am talking about the influence of acceleration due to gravity on the force, and with some sample questions, especially on this law of conservation of momentum. Thanks for watching this video. If you like the video, like on the like button to get the 3 likes, and you can also sub the channel and also drop a comment that you have watched the video and how it feels, and you can also drop your doubt in the comment section. Thanks for watching. Bye bye.